AWS DNS error hit DynamoDB, causing problem for multiple services and customers. DynamoDB error right in the US East one region soared shortly after midnight Pacific time, rippling through the other AWS services and affecting many customers. Monday got off to a bad start for Amazon Web Service users served by the company's US East one region when a DNS problem rendered the DynamoDB API unreliable, with consequences for many AWS services and customers. Although the root cause of the incident apparently affected by a single API in just one of many AWS CUDA regions, it provided a key database service on which many services, Amazon's own and those of its customers, were built in that other regions. AI search company Perplexity was one of those affected by the incident, reporting that it was experiencing an outage related to an AWS operational issues. And although the online design tool Canva didn't name AWS as the source of its problem, it reported the major issues with its underlying code provider, resulting in increased error rates for its users during the same time window. Real-time monitoring service Down Detector noted that outages at Venmo, Roku, Lifty, Zoom, and the McDonald's apps were possibly related to issues in Amazon Web Service. The increased error rates. AWS itself first reported the incident on its service health status page at 11 a.m. Pacific time, saying we are investigating increased error rates and latency for multiple AWS services in the US East one region. A little over an hour later, it had narrowed the problem down the DynamoDB endpoint, which it said was also affecting the other services, and half an hour after that, the company reported based on our investigation, the issues appear to be related DNS resolution to the DynamoDB API endpoint in US East 1. We are working on the multiple parallel paths to accelerate recovery. By this time, it was clear and the problems were not confined to users and services on the US East Coast. So global app services or features that rely on US East 1 endpoints, such as IAM, updates, and DynamoDB global tables may also be experiencing issues, it said. By 2:27 a.m. Pacific time, a little more than 2 hours after it began investigating the incident, the company reported that it had applied initial mitigations and recommended customers retry failed request, warning that there may be additional latency as some services had a backlog to work through. 3 hours after it began its investigation, the company reported that global services and features reliant on US East 1 had recovered and promised further update when it had more information to share. Cloud dependencies. While the outage was quickly fixed, it showed that even in the cloud there are single point failures that can have worldwide consequences. A few months ago, it was Microsoft with an egg on its face as a problem in the Azure US East region rippled out to affect other organizations. Before that, a series of outages at IBM Cloud had customers wondering if they had made the right decision choices. The third, shorter outage affected 54 of IBM cloud services. NVIDIA still needs Taiwan even as TSMC ramps Blackwell production in Arizona. AI Arm still relies on Taiwanese advanced packaging plant for top speed GPUs. U.S. manufacturing of NVIDIA GPUs is underway, and CEO Jensen Huang is celebrating the first Blackwell wafer to come out of TSMC Arizona chip factory. However, to be the part of the complete production, those chips may need to visit Taiwan. NVIDIA first announced plans to produce chips at Fab 21 just 6 months ago. Speaking during an event in Phoenix on Friday, Huang routed TSMC's manufacturing prowess while pandering to U.S. President Donald Trump's America First agenda. This is the vision of President Trump of the reindustrialization, to bring back manufacturing to America, to create jobs, of course, but also this is the single most vital manufacturing industry and the most important technology industry in the world, he said. But while the silicon may be homegrown, NVIDIA remains reliant on a Taiwanese packaging plant to turn those wafers into its most powerful and highest demand GPUs. The NVIDIA Blackwell GPUs powering the B100, B200, and GB200 accelerator features a pair of vertically limited compute dies which communicate with each other via a 10 terabyte per sec NVIDIA HBI interconnect. Click to enlarge. The modern GPUs are composed of multiple compute and memory dies. The company Blackwell, the family of the data center chips, feature two rectangular-sized compute dies along with 8 stacks of HBM3E memory, and all stitched together using TSMC's CoWoS and packaging tech. Up to this point, all of TSMC packaging facilities have been located in Taiwan. Amkor, an outsourced semiconductor assembly and test service (OSAT) provider, is working on building an advanced packaging plant in the U.S. capable of stitching together silicon dies using TSMC chip-on-wafer-on-substrate CoWoS tech. But until it's done, expected in 2027 or 2028, the next stop for NVIDIA wafers will likely be Taiwan. During TSMC's Q3 earnings call last week, CEO C.C. Wei confirmed the Amkor plan was moving forward, but the site was only now breaking ground. It's worth noting that while NVIDIA's most potent accelerators rely on CoWoS, not all of which Blackwell chips do. The RTX Pro 6000, a 69GB workstation and server card aimed at AI inference, data visualization, and digital twins, does feature a single CPU die fed by GDDR7 memory-loaded HBM3E. This means that NVIDIA doesn't need CoWoS to produce the chip. The same is true for the much of NVIDIA's RTX family of gaming cards. So long term, NVIDIA isn't limited to TSMC or Amkor for packaging either. NVIDIA has already announced plans to produce GPU tiles built by the TSMC for Intel client processors that will presumably make use of the x86 giant EMIB and their for various advanced packaging technologies. NVIDIA hasn't said which are the first Blackwell wafers to roll off Fab 21 production line. ELAG has reached out for clarification. We'll let you know what we hear back. Next one is Texas Instruments on its path to 95% in-house manufacturing by 2030. An exclusive interview with TI's EMEA president on growing internal capacity with in-house fabs and design agility, plus its plan in India. On its mission to increase self-reliance in semiconductor production, Texas Instruments TI has set a target to grow its internal manufacturing capacity to more than 95% by 2030. Stefan Bruder, President Texas Instruments Europe, East, Middle East, Africa, and India, EMEA, said that the company is investing in a facility. I think I read already. Let it. Okay, next one is the first 3nm PCIe Gen 6 switch to drive next-gen AI infrastructure. The new switches are designed for deliver increased bandwidth, low latency, and advanced security for HPC, AI, and data center applications. What you learn. The details behind the Microchip's switch tag is 6 PCIe fan-out switch family. What performance grade do they bring over previous solutions? According to the Microsoft technology, it launched for the world's first 3nm PCIe Gen 6 switch with a switch tech Gen 6 PCIe fan-out switch family, which is designed to power modern AI, HPC, and hyperscale data centers. The switches in family offer double the bandwidth of PCIe 5.0 up to 64 gigatransaction per sec per lane, while providing 160 lanes of connectivity, low latency, and reduced power consumption. Built on the 3nm process, they serve as a significant leap in performance and efficiency for next-gen compute architectures. The switches also incorporate post-quantum safe cryptography, secure boot on hardware root of trust, within the CNSA 2.0 standard to ensure data integrity, in addition to support for Flow Control Unit, FLIT, board and forward error correction, FEC. As a result, they were suited for AI and data analytic workloads. Each switch tag Gen 6 device features 20 ports and 10 stacks, along with a hot plug and the surprise plug controller, non-transparent bridging NP, ND, NTB for multiple host domains and multicast capabilities. A built-in MIPS processor enables advanced diagnostic, error containment, and dynamic bifurcation at 8 times and 16 configurations. Rapid innovation in the AI era is promoting data center architecture to move away from the traditional designs and shift to a model where components are organized as a pool of shared resources, said Brian McCarson, VP of Microchip's Data Center Solutions Business Unit. By expanding our proven SweetTech product line to PCIe 6.0, we are enabling this transformation with technology that facilitates direct communication between the critical compute resources and deliver the most powerful and energy efficiency switch we've ever produced. According to Microchip, developers can use chip-link diagnostic tools via an intuitive GUI for configuration, debugging, and performance analysis, while the PM61 160 Kit Evaluation Board provides hands-on testing for system architects. The samples of system switch tech Gen 6 PCIe switches are now available to qualified customers. That's why NVIDIA's $100 billion deal with OpenAI is a win-win for both companies. OpenAI will use NVIDIA chips to build massive systems to train AI. NVIDIA is investigating as much as $100 billion into OpenAI, which will in turn use its hardware to build massive 10 gigawatt AI clusters. The deal links up two of the giants of AI, with OpenAI sparking the recent boom and NVIDIA powering much of it. The partnership, described a letter of intent, will see OpenAI rolling out at least 10 gigawatts of NVIDIA systems to train and run its next generation models. NVIDIA is expected to invest $100 billion into tranches as the systems are deployed, helping to pay for the work while also giving the GPU makers a further stake in its customers. The first phase is set to come online in the second half of next year, using NVIDIA's Vera Rubin platform, OpenAI said. The NVIDIA CEO Jensen Huang told CNBC that the 10 gigawatt system was the equivalent to 5 million GPUs, as much as the company will ship this year. This is a giant project, Huang said. Everything starts with the compute, and Sam Altman, CEO of OpenAI, compute infrastructure will be the basis for the economy of the future, and we will utilize what we are building with NVIDIA to both create new AI breakthroughs and empower people and businesses with them at scale. A win-win for OpenAI and NVIDIA. Here's how the deal will work. As each gigawatt of NVIDIA's technology is deployed by OpenAI, NVIDIA will invest $10 billion into OpenAI. Analysts noted that the deal certainly makes it look as though NVIDIA's investment is being used to buy NVIDIA's product. NVIDIA invested $100 billion in OpenAI, which then the OpenAI turns back and gives it back to NVIDIA. Brian Talkington, managing partner and Recusite Capital Management told CNBC, "I feel like this is going to be very virtuous for Jensen. On the one hand, this helps OpenAI deliver on what are some very aspirational goals for compute infrastructure, and helps NVIDIA ensure that the stuff gets built. Bernstein analyst Stacy Lascon told Reuters. On the other hand, the circular concerns have been raised in the past, and this will fuel them further. Beyond that, NVIDIA has been named by OpenAI as preferred strategic compute and networking partner for its AI factory plans, and the two companies will co-manage their roadmaps. This includes closer collaboration on development of OpenAI models, as well as deployment of NVIDIA's hardware and software. Full details of the partnership will be finalized in the next few weeks, the company said. Continued partnerships. OpenAI and NVIDIA have been working closely since the advent of the generative AI boom in late 2022. The latter has emerged as a leading player in the hardware space, driving the systems that underpin much of the tech industry's efforts on this front. We've been working closely with NVIDIA since the early days of OpenAI, said Greg Brockman, co-founder and president of OpenAI, in a statement. We've utilized their platform to create an AI system that hundreds of millions of people use every day. NVIDIA took part in a $6.6 billion funding round for OpenAI last year, and alongside OpenAI and Oracle, as part of the US infrastructure project known as Stargate. So by locking in OpenAI as a strategic partner and co-optimizing hardware and software roadmaps, NVIDIA is ensuring that its GPUs remain the backbone of next-generation AI infrastructure. Hargreaves Lansdowne analyst Matt Richman told Reuters, "The market is clearly big enough for multiple players, but this still underscores that when it comes to scale and ecosystem depth, NVIDIA is still setting the pace and raising stakes for everyone else. Make sure to follow the IT Bureau, blah blah blah." Next one is it's about the China's latest GPUs arrives with claims of CUDA compatibility and RT support. Fenghua number 3 also boasts 112 GB more or plus of HBM memory for AI. The third time may finally be the charm for Fenghua GPUs. So while Innosilicon technology products may not be preliminarily featured on the list of best graphics cards, the company has been hard at work developing its Fenghua translated fantasy the series of graphics cards, as IT Home reported. Innosilicon recently unveiled the Fenghua number 3, the company's latest flagship GPUs. The company promises that the third GPU iteration is a significant advancement over its predecessors. While previous Fenghua number 1 and Fenghua number 2 graphics cards were based on the Imagination technology Power VR IP, the new Fenghua number 3 leverages the open source RISC-V architecture instead. The graphics reportedly borrows a page from OpenCore Institute Nanhu V3 project. The company representative didn't provide any more details on the Fenghua number 3 during the launch event, only that it features a homegrown design from the ground up. The Fenghua number 3 is also purportedly compatible with NVIDIA's proprietary CUDA platform, which could open many doors for graphics cards if it holds true. Fenghua number 3 is designed for a bunch of the different workloads, and Innosilicon describes as all-function GPU translation. The company plans to deploy the graphics card in different sectors, including AI, scientific computing, CAD work, medical imaging, and gaming. Therefore, it's safe to assume there will be other variants of the Fenghua number 3. The Fenghua number 3 is a jack of all trades. From a game the perspective, the Fenghua number 3 claims support for the latest APIs, including DirectX 12, Vulkan 1.2, and OpenGL 4.6. The graphics card is also reportedly equipped to support ray tracing. The team demonstrated the Fenghua number 3 as titles such as Tomb Raider, Delta Force, and Valorant at the press conference, and the report claimed that the gameplay was smooth. However, there was no available information on game settings, resolution, and actual frame rate, so take these claims with a grain of salt. The Fenghua number 3 reportedly comes equipped with 112 GB plus of HBM memory, making an ideal product for AI. A single Fenghua number 3 can handle 32-byte and 72-byte LLM models. 32 billion and 72 billion LLM models. while 8 of them is in unison work with the 671 billion and 685 billion premier models. InnoSilicon claims unconditional support for the DeepSeek V3, R1, and the V3.1 models, as well as the Qwen 2.5 and the Qwen 3 model formulas. InnoSilicon also boasted that Phonghua No. 3 is China's first graphics card to support YOV 444 format, which offers the best color details and fidelity, a feature particularly beneficial for users who perform intensive CAD industrial work or video editing. The manufacturer also highlighted the Phonghua No. 3's support for 8K 768 times by 4320 displays. The graphics card can drive up to 6K, 8K monitors at 30 Hz. The Phonghua No. 3 was the first graphics card to offer native support for the DICOM, digital imaging and communication in medicine. It enables the precise visualization of X-rays, MRIs, CT scans, and ultrasound on standard monitors, eliminating the need for costly, specialized, grayscale medical displays. The China semiconductor industry is gradually improving, although it is unlikely to rival that of the United States in the near future, and may not necessarily need to do so. China's primary goal is to achieve self-sufficiency in key areas. Announcements such as the Phonghua No. 3 may seem insignificant individually. Collectively, they might amass in a substantial progress, akin to accumulating grains of sand that eventually form a small beach. Small beach, not beach. Next one is the China's custom HBM. Huawei's custom HBM challenges the existing memory hegemony. China is moving aggressively into the high-performance DRAM market dominated by the Samsung Electronics DRAM market dominated by the Samsung Electronics SK Hynix, with each site set on a customized bandwidth memory HBM. The push for self-sufficiency is forcing the South Korean chipmakers and rethink. So, thank you for your time. See you next time.